Hello everyone, I welcome you all for the lecture 3. Here we are discussing about the components of geographic information system, and this video is on behalf of Center of Excellence in Land Administration and Management, an initiative of DILRMP, Department of Land Resource, Ministry of Rural Development, Government of India, currently housed at the Administrative Training Institute, Government of Karnataka, Mysore. So in the lecture 1 and lecture 2 we have discussed about different aspects of GIS and the supporting technologies that is helpful for us for the land administration and management. So in this particular lecture we are mainly discussing about what are all the main components of GIS and what are all the components going to perform for the mapping of geographical space. So in general, in a broader perspective, the GIS broadly classified into 5 different components: the hardware, software, data, people and method. So one by one we will explore and we will see how every component will contribute for the geographical mapping and visualization. The hardware component of a GI system. The hardware component is nothing but what are all the instruments that we use for collecting the data, storing the data, manipulating the data, processing the data and also to visualize the data. For example, the computer system, the monitor used to display the information, that is also a part of hardware component. Keyboard which is used to input the data, that is also a part of hardware component. And all the survey instruments like a GPS, like a satellite, like a drone, like a total station, all the physical component of a system, we call that as a hardware component of a GIS system. So these are important even if we work with the traditional mapping and also in the modern mapping tools. So in the traditional mapping, the chains, the rods, the tapes, whatever in the early days that we used, that are also the hardware components. But nowadays if we talk about the GIS uses the modern information technology systems which comprises of the hardware systems that used to collect the data about the geographical space. Then the second component of the GI system is the software component. The software component is nothing but the logical component where the softwares are built to handle the spatial and non-spatial data. As we discussed that regarding the spatial is derived from the space is nothing but the surface of the earth. The locational information and the metadata, the attribute of the information, both need to be tied up together to do the analysis. So the GIS software are classified into broader category. The first category of the GIS system is the desktop GIS, where the softwares are installed at the computers. The desktop computers or a laptop, it can be anything, and these desktop GIS will perform all the collection part, editing part, visualization part, everything at the desktop computers. And the GIS software, again one more classified into the mobile GIS, where the softwares are designed to work with the handheld equipments like mobiles. Best example is our Google Maps. The Google Maps is a mobile GIS application where we use the Android app or iOS app, whatever the platform you are using. So based on that, we can able to use the mapping application. So that will be called as the mobile GIS. Uh, then another type category of the software is the spatial database management system. So we have a different database managements like MySQL, PostgreSQL, Sedona, Apache, DuckDB, PostGIS. So a lot of database management systems are there. So if our the size of the data is very small, then database management is not required. If the data size having very high and the volume of the data is very high, means we should have a capability to handle those data in a efficient manner. In such case, the database need to be used to store the both spatial and non-spatial data. So that comes under the spatial database management system. And another type of the software is the web map server, where we use the software to render the geospatial data sets through the servers. The best example is the Geo server or Arc server. Both software will serve the data over the browser. Like we are getting the data through the Google Maps. Even though the Google Map app is a mobile GIS, but whatever the data we are getting from the Google Map, whatever the base map, the satellite imageries, the road information, the point of interest information, whatever it is coming, majority of the data will be sitting in the server, and those data will be fetched dynamically through the help of the web map server softwares. Then the server GIS, then web GIS, client, these are all the different aspects of the software. So if we look into the desktop GIS to do the mapping tasks with respect to the land management or land surveying applications. So majority we depend on these software in the market. So the entire software can be classified into two categories. One is the commercial software and another one is the open source software, where the commercial softwares are by the vendors, and you need to pay the money, some money to get the licenses, whether you are a personal user or a perpetual user, or you are the institutional users or a business user. So according to the type of the user, the pricing of the software will change, and by paying the prescribed money, then we can able to get the software. So that means there is a financial component included in the commercial software. But if we look into the open source softwares are developed by the group of communities, where the constant developments are happening, where these open source softwares can be modified, these softwares can be redistributed, and these softwares can be altered on our own purpose. So if we look into the market leaders in the GIS industry, the ArcGIS Pro, ArcMap, these two are commercial software which is leading the entire geospatial market, which is developed by the company called ESRI, Environmental System Research Institute. And if there is a financial constraints regarding the purchase of the software, then we can go with the software called QGIS. Early we call that as a quantum GIS. This is an open source, anyone can use these softwares, and this QGIS software is available in all the platforms like Windows operating system, Linux operating system, and even in the Mac. But if we look into the ArcGIS Pro, this majorly written to run in the Windows operating system. Suppose if you have a Mac or if you have a Linux, then ArcGIS is not a solution for that. So we have to go with the open source QGIS. So according to your requirement, you can choose which software you need to work with. Either you want to go with the ArcGIS Pro, or whether you want to go with the QGIS. It's up to you to choose which one you need to work. In order, if we look into the difference between ArcGIS and QGIS, both will perform almost similar task. There is no much difference, but the interfaces are different, and the power of computing also different. The hardware and memory consumption will be different. It's up to you to choose which software you need to work with. Then the third component of the GI system is the people. It is nothing but the manpower. So without a manpower, we cannot able to develop the GI system. So the peoples are the main integral part of the GI system. The people component of the GIS refers to user who interact with the GIS technology, make decisions and derive insights from the spatial data. So we have a different levels of manpower, and each role and responsibilities are different across the industry. So the first end user is the end user. So end user is nothing but the individual, those who utilize the GIS application, like us, like you, all are the end users. So we mainly use this software for in order to perform the day-to-day tasks. And the second type of users will be the GIS analysts, those who analyzes the data, and those who analyze, those who checks those who do the sanity checks. Sanity checks means whether the data is accurate enough for the spatial analysis or not. If the data is not accurate, then what are all the things need to be taken care of. So everything that can be done through the GIS analyst. So once the spatial data passes through the preliminary quality checks and quality assurance will be done. Once the data is clean enough, then we can do the modeling and we can able to prepare the maps. That is the role of the GIS analysts. Then the third category of the manpower is the GIS developer. The main goal of the GIS developer is to program, who need to develop new tools, new scripts, new module for the software. Suppose if any new algorithm came to the market to solve the particular problem, means then the GIS developer task is to integrate those algorithm within the software. And the day-to-day maintenance of the software, day-to-day maintenance of the servers, those things will be done taken care of by the GIS developers. Then the third category of the manpower is the GIS administrators. So in the GIS administrators, those who admins the databases, the servers and the infrastructure. So large data can be handled by the database administrators, where their main task is for the CRUD applications. CRUD means the create, read, update and deletion of the data. These things are taken care of by the GIS administrators. And another category of the manpower is the researchers and the academicians. The researchers, R&D purpose academicians, like teachers, professors across the various academics, universities, institutes. So those who advances GIS methodologies and do the case studies in the different domains. Then another category of the people will be the policymakers and the planners, like government officials who use the GIS for urban planning, disaster management and other applications, and finally for the policy formulations, like the in India, Department of Science and Technology is a policy maker, Survey of India is a policy maker, Ministry of Rural Development, Ministry of Panchayati Raj. So all the different uh, categories of ministries will act as a steering body for different policies. So they'll utilize the GIS for policy formulation and to bring out the sustainable goals for the particular nations. Another category of the manpower is the field data collectors, where the individual who will collect the data at the ground, preliminarily from the ground, like you through the different instruments like a GPS, like a total stations, like a drones, right? Even the remote sensing tasks at the ground, like using a lidars. Everything will come under the field data collectors or the surveyors. So this is limited number of manpowers which I have listed, but there are a number of peoples, those who continuously works with the GIS. Even the vendors, those who develop the softwares, those are all comes under the manpower component of the GIS system. Then another component is the data component. Without a data, we cannot able to do anything. No analysis can be done. So the data is fuel for the any analysis. Where in GIS we broadly categorize the entire data into two categories. One is spatial data and another one is non-spatial data. The spatial data is relating to the space, which is relating to the coordinate, the dimension, the aerial aspects of the particular feature. And the non-spatial data is about the attribute information about the particular feature. So let us take the example where there is a place. Let us take the example from the Mysore. In the Mysore palace, the total area, the boundary of the area, boundary of the Mysore palace will become spatial data, and the palace name, the palace king name, and number of floors, right, number of gates, opening time, closing time. So these are all the things comes under the non-spatial data. So without data, GIS we cannot able to perform, and we cannot able to perform the analysis. So this is the flow chart of the data, how it broadly categorized. The spatial data and non-spatial data. The spatial data relating to the space. So especially in GIS we have two types of data. One is vector data and another one is raster data. So we will discuss what is vector data, what is raster data in detail in the upcoming lectures. Where in the vector data we use point, line and polygon to represent any geographical feature on the earth, if it is discrete in nature. And we use raster data in the form of images to represent the continuous information, like temperature, like rainfall, like elevation. We use the raster data. So it is depending on the scenario whether we want to create a vector data or whether we want to create a raster data. So in the upcoming lectures you can able to distinguish whether you can go with the vector or a raster. So we will discuss with the case studies as well. And in another side, the different type of data is the non-spatial data. The non-spatial data, the text based information, image based information, even the audio, the video, all the non-spatial data can be tagged to the particular location through the point, line and polygon. So once we embed both the spatial and non-spatial data, then these data will bring the meaningful information and will bring the insights regarding the particular location. So by this I am ending the lecture 3, and we will meet in the next lecture 4. Thank you everyone. Please visit us by scanning the QR code and follow us at the Instagram, YouTube, LinkedIn, and write us if you have any queries through this Gmail ID. Thank you everyone. Have a nice day.